These are momentum concepts by standard, and we're going to go through number 1 through number 15. The first one says the momentum of an object is defined by or as the object's mass times velocity. So you'll notice here, this is our equation. Remember we said that they use P for momentum, M is mass, and V is velocity. And your final units for momentum are a kilogram meter per second. Which has more momentum, a large truck traveling at 30 miles per hour or a small truck moving at 30 miles per hour? For this one, if we remember, the thing that has more mass or the thing that has more speed, if the other are the same, will have more momentum. So for this one, the large truck, because it has more mass and because they're moving at the same speed, will have more momentum. Number 3, compared to a sports car moving at 30 miles an hour, the same sports car, so here's our sports car, moving at 60 miles an hour has, and the answer is twice as much momentum. If it's moving at 30, we have 30 momentum units. If it's moving at 60, there's 60, so we just know 30 times 2 would be that 60. For number 4, if the momentum of an object changes and its mass remains constant, this thing has got to be accelerating or decelerating. Because the momentum is changing and the mass is the same, remember our equation is P is equal to M times the change in velocity. And if this isn't changing, then this velocity has to change. Remember, velocity changing is equal to acceleration. That's the same thing. There's got to be force on it. Remember, force is equal to mass times acceleration. And we just said that if it's accelerating, then the velocity has to be changing. And the last answer is its velocity is changing. So this is a problem or a question that you'll see that will have multiple answers to it. For the next question, number 5, it says, which of the following has the largest momentum? A pickup truck traveling down the highway would have the most momentum. If it's a large truck and it's parked, we know that the V is equal to 0, so your P is equal to 0. A tightrope walker crossing Niagara Falls, that would have a really small mass, and so its momentum would then also be very small. The speed of that person would also be small too, so you could look at it that way. And the science building at any particular college, because it's not moving relative to the surface of the earth, we would say it has no speed, therefore it has no momentum. Number 6, a freight train is rolling along a track with a lot of momentum. So because it's so massive, if we were to roll this at the same speed but it had twice as much mass, so let's say it's carrying twice as much cargo, its momentum would be, well, let's look at it one step at a time. Let's just say that's 1,000 kilograms, even though it's a lot more than that. And it's moving at 10, we know that that's 10,000 units of momentum, or kilogram meter per second. If you double the mass, so now we've got the mass at 2,000, we multiply that times 10, we get 20,000 kilogram meter per second. So 10,000 divided times 2, 10,000 times 2 would give us 20,000. So we notice that it does double. Number 7, two objects, A and B, have the same size and shape, but A is twice as heavy as B. So it's got twice the mass. Well, we know that from our equation, if we take M and we increase it to 2M times V, we go from original P to 2P. So it says when they're dropped simultaneously from a tower, they reach ground at the same time. So both these objects, the small one and the one that's double the size, they would both hit at the same time, and they would both have, but A would have the higher momentum. So, here's A, it's twice as big as B, and when it hits the ground, even though they have the same speed, remember the momentum of this one is going to be 2 times mv, because it has twice the momentum, twice the mass. Acceleration is the same for each of these. Remember, that's g, and because they fall the same distance in the same time, then the speed is exactly the same. Number 8 in the conceptual question says a 2-kilogram bowling ball is thrown at 3 meters per second. What is the ball's momentum? So all you had to do is multiply the 3 times 2 and you get 6 kilograms meters per second. Number 9 is another math type problem. This one they do it a little bit differently. You have a 4-kilogram ball, has a momentum of 20. And so if you rearrange the equation and to solve for the ball's speed, you end up with 20 divided by 4, which is 5 meters per second. Number 10, a ball is moving at 6 meters per second and has a momentum of 24 kilogram meter per second. They want to know what the mass is. So now we're solving for mass. We just take the momentum, divide it by the speed, so 24 divided by 6, and you end up with 4 kilograms. Number 11, in order to catch a ball, a baseball player moves his or her hand backward in the direction of the ball's motion. When you do this, it reduces the force of impact on the player's hand, mainly because the time of impact is increased. So if you don't pull back, you feel a lot of force. If you do pull back, that force is small because the T is very, very big. Number 12, a car traveling along the highway needs a certain amount of force exerted on it to stop. More stopping force may be required when the car has, there's several answers here. The first one is less stopping distance. If it doesn't have to stop, if it has to stop in a much shorter distance, you have to push harder on the brakes. More force, more acceleration. More momentum, more mass or a higher speed, then you would need more stopping force. And finally, just more mass. That would mean that you would have more momentum, so it takes a little bit more force to stop your car. Number 13, this is a good one. When you jump off a step, usually bend your knees. If you didn't, it would do some pretty bad damage to your legs. So by doing this, you reduce the impact on your knees. So here's this lady's knees by about 10 times than if you had a stiff-legged landing. The average force on your body is also reduced by about 10 times. If she tried to land with her legs straight out, that would not be good for her body. She wouldn't be able to jump for very long. Recoil is noticeable if you throw a heavy ball while standing on roller skates. So if you had a big ball, like a medicine ball, and you threw it forward, your body would go backward. If instead you go through the motions of throwing a ball but you hold on to it, your recoil velocity would be 0. So basically what would happen is you would be holding on to that ball. So let's just say that you're facing this way, you're standing on roller skates, you've got this big ball. You would push it out, and then you would push it back in, and the reaction would be your body would go this way, but then it would come right back to its original position. So your recoil velocity, your net recoil velocity, would be 0. The last question is number 15. It says a 1 Newton apple falls to the ground. The apple hits the ground with an impact force of 1 Newton. That one's a pretty simple problem. And those are number 1 through 15 for momentum.